In the next 15 minutes or so, I will be walking you through step by step how to create your first coaster project with BlockLogic Studio and BlockLogic Runtime. When you're seeing this video, you most likely have early access to my project. If so, thank you very much for helping me make this even better. And everything I will be showing in this video is also available in a written form with additional information accessible through the home screen of BlockLogic Studio. Today, we are going to recreate a coaster that is in the base NoLimits 2 game, which is the script park. We will be recreating the block logic of this coaster using BlockLogic Studio. And as a quick reminder, if you haven't looked at this park in a while, this coaster has two switch tracks. First one here, where you enter forward into this block, then the switch changes and you launch out backwards. And at the end, in the final brake run, there is a transfer table where you enter in backwards, then you move over to the middle track and then leave forward. Since this is a built-in park, it is a read-only park, we will not be able to save any of our modifications. So the next time you load this park, everything will be set back to what Ole has created when he did this demo park. All right, with that said, let's get started. First things first, we need to go to the coaster tab and the coaster properties, then change to scripts and remove the block script. Once we did this and go into the simulation, we will see that nothing is happening. The coaster is not moving as there is no script telling the coaster what to do. We are now going to change this by, again, going to the coaster properties and to scripts. Now we have to select the BlockLogic Runtime. To do so, you have to first download the BlockLogic Runtime package and unpack it into a folder. To connect a script to this coaster, we click on Add from File, and then we go to the location where we saved the BlockLogic Runtime package. In my case, that's M downloads. In the package, we will find the BlockLogic Runtime. We select it, click OK, and we have it assigned to this coaster. Again, press OK, start the coaster, and we will see that still nothing is happening, except that we now have a console telling us that the script was loaded successfully. Next up, we need to add a setup configuration object to the park. To do so, we go to the Scenery tab, we go to Choose. Again, we go to the BlockLogic Runtime package. In here, we select the BlockLogic Runtime setup, and we place it somewhere close to the station. The location doesn't matter, but it's good convention to have it close to the station to find the setup object later. All right, we double click this object and we start to configure it. All we need to do right now is we need to configure it to use the Cursing Mummy coaster, which links the configuration file, which we will be creating later, to this instant of BlockLogic Runtime. If we again go into the simulation, we see that still nothing is happening, but we found the setup object and our configuration file obviously is missing as we haven't created it. And exactly that is our next step. We are going to create the block logic using BlockLogic Studio. Welcome to BlockLogic Studio. We are starting with a new project. So we click on New Project. We select Import from Park File, and in here we need to drag and drop the script park file. If you are a Steam user, you need to open the installation directory of NoLimits. You can do so by right-clicking NoLimits 2 in Steam, going to Manage, and then Browse Local Files. Then go to Park, Script Park, and then drag and drop the script park NoLimits 2 park file into the application. Just like that, we select the Cursing Mummy. Then we give this project a name. This is the demonstration park. We can overwrite the author. This is loaded from the park file, which was created by Ole. And to have a clean setup and don't confuse ourselves with sections we don't need, we're going to do two things to our imported sections. First, we remove all transport sections. That's the yellow ones, as we don't need them for this setup. Then we do the same to the storage sections. We also don't need them for our demonstration. And then we also remove the trim blocks as we don't need them. Here's a trim brake section. We delete that. And there's another trim brake section. We delete this as well. With that, we should be left with 7 sections, 2 special tracks, and 0 triggers. Let's create the project. When the project is created, we can find those objects all in our library under special tracks as well as sections. We can add or change all of those objects at any time. In fact, let's add an object. Let's add a track trigger. And to do so, we first, of course, need to add one in NoLimits. So we go back to NoLimits, into the editor. We unfreeze our coaster and we place a track trigger just after the first switch track. And we will be using this track trigger later to instruct the switch track to switch back once the train has left the switch. So let's place a track trigger here, give this track trigger a name. Let's call it switch 1 reverse. We copy that name. We go back to the BlockLogic Studio. In the track trigger section, we click add trigger. We give it the name we just set in NoLimits and click go back to library. We now have added this track trigger. To make our lives a little bit easier, we go to the libraries and then templates. Here there will be different templates to get started quicker. And let's import the basic BlockLogic template package by clicking import, select all and continue. This now should have imported a total of 2 routines, which is the basic check clearance and release, and the basic check clearance and launch routine, as well as 5 rules: basic revert block to idle, basic prepare block for entry, station set clear, station handoff to station, and station take over from station. Okay, so we have created all the objects we need to get started in BlockLogic Studio. And to start creating our BlockLogic, we can switch to the block editor in which we design the logic flow. Our next step is now to create the blocks this coaster will have. And to do so, we click on the plus sign, which will add a block, and we name this first block loading station. Then we add all the other blocks that this coaster will have. And this will be a total of 6 more blocks. So I add 6 more and we arrange them in a somewhat logical order. Let's give all those blocks a name. We have the loading station. This loading station will head into the lift station. The lift station will head into before launch. Before launch will head into the switch 1 hold block. Switch 1 hold will lead into switch 2 hold. Switch 2 hold will lead into station stacking, and station stacking will lead into unloading station. With the blocks created, it is now time to map the track sections from NoLimits to those blocks. Let's start with the loading station. In loading station, in the inspector window, we go to sections and then we select station enter. Press the plus button and add the section to the block. For the lift block, it will be lift. Before launch will be before launch. Switch 1 hold will be first direction change brake. Switch 2 hold will be reverse 2 brake. Station stacking will be before station. And unloading station will be station exit. In order to tell NoLimits that it is responsible for the trains in stations, we click onto the loading station and then under the logic section, select native station handler and set it to true. Same for the unloading station. This ensures that NoLimits 2 will take over from our scripts once a train enters one of those stations. But because our setup has 2 stations just behind each other, there is one extra step we need to do. And for this, we go to the rule libraries. And here for the 3 station rules, we need to assign them to both stations. Let's click on the first station rule. By default, this is already assigned to the first station. But since we have 2, we need to tell BlockLogic Runtime that this rule is also true for the unload station. We do this, click on back, go to the second station, add the unload station here as well, go back and do it for the third rule, adding the unload station, assign block, back. And now we can go back to the block editor. Next up, we need to tell our blocks what logic to run. And to do so, we go onto the load station. We select the main logic routine, which will be the basic check clearance and release. Same goes for the lift. Before launch, we'll not use the normal release, but the launch logic. Same goes for switch 1 hold. We'll also use the launch because we want to launch backwards. Switch 2 hold, we'll again use the normal release, as well as station stacking. We'll also use release. So does the unloading station. With the routine setup done, it is now time to tell the system how those blocks relate to each other. To do so, we hover over a block and grab this handle and drag it to the next block in order. So from loading station, we move to lift. From lift, we move to before launch. From before launch to switch 1 hold, to switch 2 hold, to station stacking, to unload station, and to loading station. Now we have defined the flow in which a train will move from one block to the next. However, right now, the system assumes that all blocks are reached by moving a train in forward direction. For our example, this is incorrect, as after switch 1 hold, we will be leaving the block backwards. To change this, we click on the connection between switch 1 hold and switch 2 hold. And in the inspector, we go to directions, and for the exit and entry direction, we change this to reverse. What this indicates is that when the train is leaving switch 1 hold, it is leaving in reverse direction. And when the train is entering switch 2 hold, it is entering also in reverse direction, since we haven't performed any other directional change between those two blocks. The block logic runtime now understands what blocks we have, how they relate to each other, and what direction a train needs to move to reach those blocks. However, the system does not yet know what switches to throw in order to reach the correct block. To do so, we also need to add the special tracks to our block connections. So let's first head back to NoLimits to get a clear view of what we need to configure. The first switch track is this switch track over here with the name reverse 1 switch. In the default track number 1 configuration, we accept a new train coming in from the trims into the block. And if we switch to track number 2, we have the switch aligned for the launch backwards. So what we need to do is we need to go to the studio. We need to go to the before launch to switch 1 hold connection, click on it, then go to validation. In validation, add the reverse switch 1, and then tell the system that in order to reach switch 1 hold from before launch, the switch needs to be in position 1 and needs to be locked. So no other train can change this switch position when this train is approaching. We now need to do the same for the connection from switch 1 hold to switch 2 hold. We click on the connection, we add the switch 1, and this time we need to have it on position 2. This time we do not lock the switch track, as we want it to be movable before the train reaches the next block in order to increase throughput. More about this in just a moment. But in addition to switch 1, if we take another look in the sim, we also need to configure switch 2 to be in the correct position, as those sections here are no block sections, they are just trim breaks, so there's no means of stopping the train before rolling into the switch track. This transfer table has the name reverse 2 switch. So we go back to the studio, still on the connection from switch 1 hold to switch 2 hold. We go to validation, add the reverse 2 switch, edit, and have it in position 1, locked. When we are on this block, we need the entire table to move over to the middle position in order for the train to reach the station. And to configure that, we get to the connection from switch 2 hold to station stacking, click on the connection, add the validation for reverse 2 switch, and set it to position 2, also locked. Right now, our block logic is pretty much done, but I already teased it. We want to use the track trigger we set earlier in NoLimits to be able to switch back the first switch when the train has left the switch. And to do so, we go to the triggers page, go to the track triggers tab, and add a new trigger action. Then we select the trigger that we created, which is the switch 1 reverse. We define if we want to trigger something when the train enters or leaves it. In this case, we leave it on enter. And then we add an action. Let's add an action And in our action library, we search for Q switch alignment. We click on this action and again to configure it. This action will queue a switch track alignment. We select the switch ID, which will be reverse one switch, the first switch we want to change, and we want to change it from its current position back to position 1. Then we hit create trigger action and we are pretty much done. The only thing we now need to do is we need to tell the BlockLogic runtime to do what we just set up. And to do so, we need to export the BlockLogic runtime configuration. We go to File, Export Config, and we can now save the configuration anywhere in our system. It is best to place it next to the BlockLogic runtime package. So this is again in my downloads folder, and we name it demo park config. We save, and now we can go back to NoLimits, go to our setup object, go to the configuration file, and browse for the newly saved file. In my case, downloads demo park config. We select this, hit OK. We have loaded it into our setup object, and now if we are starting the simulation, we should see the train move out of the station, which it does. Fast forward a bit to see if the BlockLogic is working as we expect. The train is arriving, the train is stopping, the switch is switching to position 2, train is launching backwards, and after triggering the trigger, the switch is going back to the first position. Let's continue to the end of our layout where we have another switch. In this case, this is the table. The train is arriving, stopping on the table, moving to the second position, then moving forward to the station stacking block. And this table here will move back as soon as another train hits the block over there, where we validate the position of both tables at the same time. Once they are both locked in, the train moves backwards. All right. You just created your first roller coaster using the BlockLogic Studio and BlockLogic Runtime. If you are in the early access program and you have access to documentation, feel free to write any comments in the documentation of things you think is unclear, and I will do my best to add those to the FAQ, improve UX of the entire system, and of course create dedicated video tutorials explaining certain aspects in more detail, as we just did here with the quick step-by-step walkthrough of creating a first coaster. All right, I am Greeny, and if you want early access to the BlockLogic Runtime and BlockLogic Studio, there should be a link in the video description. If there is no link at the time, that means that I am not ready to accept more testers. Thanks for watching. See you in another one. Bye.